Hello everyone, today I am going to deliver a lecture on residual stress. In previous lecture, I have already discussed about the basic concept of residual stresses and what are the different categories of residual stresses in details. Now I am going to discuss about what are the different effects of residual stress in details. The residual stress have some good effect as well as it has some bad effect also. The bad effect in the sense residual stress especially decrease the fatigue strength, especially if the residual stress type is tensile in nature, and if the residual stress is compressive in nature, then it improve the fatigue strength. That also I have written here, because compressive residual stress increase the fatigue life of the component. This is good. Now, residual stress generally have a effect on buckling strength also. It generally reduce the buckling strength significantly, because if initially there is a buckling means what happens, it arise generally in case of column types of a structure. Column means structure which is subjected to axially compressive types of loading, compressive life, this is called column. Now, if inside this body if there is some residual stress itself, then this buckling load is decreased. This you should, because this residual stress act as the initial stress here. So, you know this critical load bearing capacity of this column decrease. That is why here we have written reduce the buckling strength. Okay. In hostile environment, this residual stress can cause cracking in the material even in the absence of applied load. What does it mean? If in a structure, if there is some residual stress itself, now if this structure goes to some hostile environment, what does it mean? That can be highly temperature condition, and that can be very cool condition. Like from some normal water temperature ship, if it go to a temperature where the temperature is minus 40 degrees centigrade, minus 50 degrees centigrade, within this range, if it is go from what it is called 20 degree centigrade normal temperature sea to that ocean, then at that time that is a hostile environment, correct. So, in that environment what happens, there can act this residual stress as a very dangerous agent, you can say. How it is, that is why what happens, due to this locked in stress at that hostile environment can generate crack, and what happens, your structure can fail. Okay. That is why here I have written, in hostile environment residual stress can cause cracking in the material even in the absence of applied load. That means a crack can generate there itself due to this change of temperature, that is in hostile environment, without the application of external load itself. That means suddenly you can say your ship is cracking somewhere without any types of hitting with any structure. Why it can occur? Because already there is some external loading inside the body, that is called a locked in types of stress. That stress act as a what is called initial stress over there, and that can create some what is called crack generation. This residual stress improving the static loading performance of brittle material. This residual stress, once we impose in some brittle material, it can improve the static loading performance using some compressive types of residual stress, like thermally toughening types of glass or thermally toughened glass, where generally once we impose this compressive residual stress by some heat treatment process, it improves the static loading performance significantly. Now, in weld, how this residual stress arise, that we should know, because here we are going to discuss about welding related residual stress. That is why. So, residual stress arise in welding due to differential plastic flow, due to phase transformation, and due to thermal gradient. What does it mean? That you should know. I will show you in subsequent slide. So, welds with higher heat input are prone to higher residual stress. So, higher the heat input, higher will be the expansion and contraction phenomena. So, higher will be the residual stress. Now, third is increased restraint in a structure or in a body generally decrease the distortion, but always keep this in mind, it also increase the residual stress significantly. In many cases, the magnitude of residual stress can even reach the yield strength of the base material. This also you should keep it in mind. So, the residual stress which ever it developed in welding, the residual stress which is developed in welding, this can reach up to the yield point of the parent material, that means the material which we are going to join. Okay. This you should keep it in mind. So, magnitude of this residual stress is dependent on geometric parameter of the weld, it also depends on weld order, it also depends on welding parameter, and it also depends on stiffness of the structure. How it is, everything I will discuss in subsequent slide. Now, here I have written the first one, differential plastic flow, phase transformation and thermal gradient. What does it mean? Which I have already told you, then also again I am explaining here. You see, once we do the welding of two plate, what I have told you, heat is applied generally one side from a arc, correct. Let this is the weld bit. So, due to this, this is the arc. So, this heat is supplying from top surface of this weld bit, here you see. So, contact between top surface and arc, in this location whatever the heat will develop, let T1, this heat developed through the thickness, that means lower part of this plate, that the temperature is T2. Now, you see here you see due to this direct contact with arc with top surface, there the temperature will be, you can say, higher than the lower surface. So, due to this thing, through the thickness there will be a variation of temperature. So, due to these things, what happens if we consider this weld thickness, weld plate thickness is consist of different layer. So, in different layer there will be different types of temperature, because in top layer T1, let this is T3, T4, T5. Okay. So, there so different layer there will be different temperature. So, due to different temperature, we know there will be different temperature difference. Now, as the material have some thermal expansion coefficient, now with this if we just temperature difference multiply with this layer, then what happens, we will get thermal expansion, or if during cooling there will be thermal contraction also. So, due to this thing there will be non-uniform expansion and contraction throughout the entire layer of this through thickness of this plate. So, this in this case one layer act as a one layer act as a locked for other layer, what I am telling, understand. So, due to this in different layer there can be stored different types of elastic strain. That elastic strain generally will develop internal stress, that is called residual stress. That things arise along the thickness, as well as if we go just with direction of this, that means away from this weld bit perpendicular direction, here also temperature difference will be different. Here also temperature difference will be, let us say here TL, Tm. So, this generally closer to this torch, this temperature will be higher, TL will be higher than definitely Tn, okay, Tn. So, what happens, gradually this temperature also varying along the width direction. Due to these things in width direction also there will be different types of expansion and contraction. So, due to these things also there will be some stress distribution, locked in stress distribution due to non-uniform expansion and contraction phenomena. This is called differential plastic flow. Then what is phase transformation? Phase transformation means once this weld is made up from steel material. So, this steel material have different phase, like it has austenite phase, it has what it is called ferritic phase, it has bainitic phase, martensitic phase. So, this austenitic phase has one types of volume due to this heating and cooling. That means, this austenitic phase will have some different types of expansion contraction than ferritic as well as bainite and martensitic structure. So, due to this non-uniform types of expansion and contraction phenomena of different phases, also there can be some locked in types of stresses. So, this is another phenomenon due to this temperature gradient, what I have already told you. Temperature gradient means through the thickness as well as through the width there will be a varying temperature distribution. So, temperature gradient is what? Change of temperature divided by change of length, that is very well known to you. So, due to this thing there will be varying what is called expansion and contraction phenomena, correct. Due to this thing there can develop residual stress. Now, here I am going to show you how the residual stress developed in a weld. This you should know. So, here little bit more details I am just showing. Let this is a weld which is formed due to welding. Now, this weld I have divided into 4 different section. You see this section, one is AA section, say another section, this section AA is ahead of the you see this is the weld till this welding is done. So, this AA section is ahead of this BB section. BB section is the welding torch position or arc position. So, ahead of this arc position is AA position which is not affected by temperature, okay, this AA position. So, in this AA position how the temperature and stress is developed, that I am showing. So, this I am showing like this. So, here you see this A section, as this is not affected by this weld bead or welding heat, that is why here the temperature difference will be 0, correct. So, as this temperature difference here will be 0, so here how the stress distribution will be. So, in this section, this AA section, so in AA section you say, so this is for section AA. So, in section AA, as the temperature is not there, so there will be no means heating and cooling types of effect, there will be no thermal expansion, there will be no contraction types of thing. So, there the stress will be, this is the stress will be 0, correct, in section A. Now, here one thing you should keep it in mind, once something is heated uniformly and if it is cooled also uniformly, if there will be uniform types of expansion throughout the entire section, if there is through the uniform types of contraction throughout the entire section, then there will not be any types of what it is called residual stress. Because once something is free to expand and once something is free to contract without any restoring types of forces inside, that body should not have any types of residual stress. That is why what happens, uniform types of heating and cooling will not develop what it is called residual stress. This you should also keep it in mind. So, in section AA, as there is no heating effect, so that is why you see there is no expansion contraction, that is why there is no stress. Now, at section BB, you see section BB, here I have just shown how it is. In section BB, here generally very high temperature is there, here generally very high temperature is there. So, this is section BB, this is for section BB. So, here you will get, there is a very high temperature and this temperature, let us what happen, this here it is, let this temperature melting point, it is cross melting point temperature of the material, and this along with direction, let this is your with direction, this is with direction, and this with direction generally this temperature gradually decreases and after some time it is returned back to room temperature. Let us here it is room temperature. Now, you see, so as this material in this zone, that means in torch location, in this torch location, as this material there is in molten state. So, what happens, this molten material does not support any types of restoring types of force, correct. What happens, because what happens, it is deformed, because once it is subjected to some expansion and as it is in liquid state, that is why what happens, it deformed. So, what happens, there will not create any types of restoring types of effect or restoring types of force. It cannot sustain any types of external types of loading. That is why what happens, in this case once we draw the stress, we will get near the, you see near the weld zone, we will get as this material is molten state, this molten material, this is let the stress, this axis represent the stress, at the stress will be 0. But just along with direction, if we go along with direction, this surrounding material, that means along with direction, surrounding material generally subjected to, which is in solid state, it can sustain some sort of what is called compressive types of residual stress. How this compressive types of residual stress is arising, that I am just showing. Because what happens, that body is subjected to, that surrounding body is subjected to some sort of thermal expansion due to temperature rise there, correct. This is due to temperature rise there. But what happens, this thermal expansion is further restricted by further distance parent material. So, you see, just after that this material is subjected to some compressive types of residual stress. Now, as this residual stress is balanced in nature, that is why this compressive residual stress is resisted by this surrounding low temperature what it is called parent material. This you should keep it in mind, because you see how it is. So, you see, so residual stress in this zone, it's look like this, we should keep it in mind. So, both side, just along the whirlpool zone the residual stress will be 0, along the whirlpool zone the residual stress will be 0. Just beside this molten metal zone, the material try to expand, but this expansion is restricted by surrounding material. So, due to this thing, what happens, this restricted material which is try to expand, but it is not expanded by this surrounding cool material. That is why inside that zone there will develop some compressive types of stress. Compressive types of stress means it try to expand, but what happens is restricted its expansion. So, what happens, as it try to expand, but it is restricted to expansion, that is why internally there will be develop some compressive types of restoring force, correct. Because this zone generally what happens, just beside this zone and this zone, just which is subjected to some temperature, but which is not liquid state temperature. Due to this temperature difference in this zone, there will be develop some what it is called, there will be develop some expansion types of phenomena, but this expansion types of phenomena is further restricted by further cool material. You see, because this temperature is gradually, this temperature you see from here, you can see this temperature is gradually varying from whirlpool zone to perpendicular direction to this welding line. So, what happens, lower the temperature in further distance, there will be lower expansion types of or contraction there. Due to this thing, during heating, here you see as this zone is try to expand, but what happens, as it is restricted by surrounding material, that is why in that zone there will develop some compression types of stress, that is called compressive stress. Now, you see, as the surrounding material is restricting this expansion of this zone, let this is zone 1, that is why what happens, this surrounding material also there will be develop some other stress, that is called tensile stress, because this surrounding material will be try to, generally you can say try to push, actually try to push this near weld zone solid material zone, that means zone 1. Okay. This you should keep it in mind. Okay. So, how this stress is varying, after that this section CC, in section CC, here I am just drawing, in section CC where the temperature, where the welding is passed through this section, the welding already passed away. So, once as the welding is passed away in this section CC, there the temperature generally reduce, and let the temperature in this zone is just lower than the melting point temperature, this section CC, because there the material start cooling, okay, and that material starts solidifying. So, as the material starts solidifying in this zone, so this is the temperature zone, this is the temperature zone, this is the temperature distribution, this is weld line, this is generally weld line, weld line. So, in weld line this temperature will be definitely more, and it is gradually along the width of the welding direction, correct, width of the welding direction. So, you see, as there is already some temperature is there, so and as this material there starts solidifying, then what happens is try to contract, is that correct, is try to, that means it start contracting. So, once it start contacting, but its surrounding material, so this material, this weld zone's material start contacting, but you see this surrounding material generally prevent that contraction, because what happens, that is that this surrounding material generally is in solid state condition, which has generally lesser expansion or lesser types of contraction in that zone, correct. So, that is why what happens, this surrounding material prevent the expansion of this zone, prevent the expansion of this zone. So, what happens, once it try to prevent the contraction of this zone, this you should keep it in mind. Why? Because what happens, in this zone the material start contacting, because it starts solidifying. Solidifying means its volume gradually decreasing. So, once volume start gradually decreasing, then what happens, there will develop a contraction types of phenomena, but that contraction types of phenomena is prevented by this surrounding material, this surrounding material. Let us what happens, once something is like this, but it's once it contact, its shape will become like this, but what happens, so the final shape will be like this, but what happens, due to the surrounding material, what happens, it is not able to return back to this lower size. So, it's remain the bigger size itself due to surrounding material. So, this zone will subjected to what types of stress? This zone will subjected to tensile types of stress, because we are preventing to make it shorter, correct. We are preventing to make it shorter, because by applying some externally applied load, then this body will subjected to what types of load? Then this body will subjected to tensile types of load, correct. So, what happens, due to this, in section CC, due to this contraction of this material and obstruct this contraction of this weld material from surrounding material, in that zone there will start developing what it is called tensile types of stress, okay, tensile types of stress. These tensile types of stress, as the surrounding material is restricted, in this surrounding material there will develop some compressive stress. Now, in section DD, which is far away from the heating zone, you can see. So, in this zone again the temperature is 0. So, in this zone generally this material contract fully, that means material contraction, that means solidified fully. Then what happens, whatever the contraction force should be there in this zone, that contraction force is its maximum level. What I am telling, understand, because it here the temperature again return back to 0, but that contraction is further restricted by this surrounding material. So, as this zone is fully solidified and as there is no temperature, that is why what happens, and as this zone's contraction is restricted by the surrounding material, that is why here in this zone there will be develop maximum tensile stress, okay. Let this is the surrounding material. So, here in this zone what happens, once the surrounding material was not there, then our once its free expansion and contraction, the final shape become like let this, okay, A1, but due to this surrounding material this shape remain as it is A2, correct. So, this is remain how, because due to surrounding material tension force, because surrounding material tension force, correct. So, in surrounding material what types of force will act? So, in surrounding material you see, in surrounding material there will develop a, because let this is surrounding material and let this is surrounding material. So, this surrounding material will experience what types of loading? The surrounding material will experience a compressive types of loading. So, this due to this compressive types of loading in surrounding material there will be develop a compressive residual stress. There will develop a compressive residual stress. This you should keep it in mind. So, this is the final shape of residual stress distribution in a weld cross section. This you just keep it in mind. So, in weld zone it is tensile in nature, and away from the weld zone it is compressive in nature, and this residual stress is self equilibrium in type. So, that means proportion of compressive and tensile stress are equal, that you can say, okay, because this is generally a self equilibrium types of condition. This you should keep it in mind. So, this x is actually a stress and this is actually distance. So, next class I will start from here. Thank you.